Hello everyone. Today in this class we are going to discuss about Module 2, that is Facility Location and Layout. We have already completed the Module 1. Module 1 videos are available. You can go for referring the videos. Module 2 we are having Facility Location and Layout and also Inventory Management. Let us start the class. So what is facility location? When we have to choose a location or place to establish the plan, because we have already discussed in our previous class that we need to first design the product, then we need to see what is the production process, what are the inputs to production process, what is the output. Output may be product or service, may be tangible or intangible. So these things we have already discussed. So to produce a product or to provide a service, we need to have some space or we need to have a place where we can go for establishment of the plant, or we have to provide the service to the customer. So for that we need to have a suitable place. So that is called the location. What is the best place to provide the service, or what is the best place to manufacture the product? That is called the location. So location is always a strategic decision. That is a long-term decision. When we are investing on land, we are establishing the plant. That is always a long-term decision or strategic decision, because we are planning for 10 years, 20 years, beyond 20 years, and it is a long-term planning. So for that, we have to have different factors. We go for analyzing different factors. If labor availability is there or not, transportation facility is there or not, raw material availability, what is the weather condition of that place. Lot of things we need to analyze. Cost is also a factor. So many things we go for analyzing. After analysis, what are the suitable factors? On the basis of that, we go for choosing the location. The plant location refers to the location of the organization. That is the place where we are going to establish our organization. Selection of specific site. Establishment of the physical units. Because when we are selecting a site or a place, we have to establish the physical units, our machines, our facilities, everything we have to give. So this is called a strategic decision of an organization. Need for plant location. Why we need to have a location? Because we have to establish the plant to produce the product or to provide the service. So for existing facility, if we have the existing facility, we can go for having a new location if there is a change in availability of resources. If we have a facility, we have a location, but the resources are no more available that place, or that is a scarcity of resources, we can go for shifting the location from that place to other where we expect the availability of resources is there. Then shift of demand. If we are providing our service or we are producing or selling our product in a particular market, but there is no demand in the market, so we can go for shifting to different place in search of a new market. To expand new target market, then develop of new technology. If there is a technological changes is there, we can go for establishing a new plant. Then socio-political and legal issues. If there is a political changes or rules, regulation of that place changed, so that is not now is not these rules and regulations are not applicable for us, or it is not provide any good input to us, then we can go for changing that place or that location to other. Plant layout. Plant layout is all about the physical arrangement of the facilities or machines, equipments, everything inside the location. We'll discuss in detail the plant layout after the location. Plant location, different factors are there. We can go for discussing the factors. Those are some factors are controllable factors, some factors are uncontrollable factors. Those factors we are able to control, that is called controllable factors. And factors which are not in our hand, we are not able to control, these are called uncontrollable factors. So controllable factors, if we see, there is proximity to market, means market should be nearby, supply of raw material, availability of raw material, transportation facilities like roadway, airways, all these facilities, railway transportation is there or not. These facilities should be available or not according to our production, our product, or according to our facility we are providing or service we are providing. We need to go for having a transportation facility. Which type of transportation we need, that we can go for deciding. Then infrastructure availability, what is the infrastructure of that place, it is infrastructure is available or not to have the location. Availability of labor and their wage, because wage rate change state to state. So what is the labor availability? That state a labor available is there or not? What is the wage rate of the labor? These things are also very, very important factors while discussing. But these factors somewhat we can able to manage or control. But uncontrollable factors are like government policy. That is no man can change this type of factors. Government policies, climate condition, supporting industries and services, community and the labor attitude of that place, community infrastructure, these things we are not able to change. These are called the uncontrollable factors. When there is a question, when if question is asked like what are the factors affecting plant location, we go for discussing the controllable factors and the uncontrollable factors. Which factors we are able to control and which are not able to control by the manufacturer or the service provider, then that is can be discussed as factors. Factors affecting plant location. So these are the factors like proximity of the market, then location of the facilities close to the market should be close, provide goods and services at time and reasonable price, reduce the transportation cost. Proximity of the market is a factor where we can go for provide the goods and services at time and reasonable price, and we can able to reduce the transportation cost. If the market is nearby, we can able to reduce the transportation cost also. Location of facility close to market based on product, like delicate and susceptible to spoilage. Like if there is very like we are providing like milk products, perishable products. So for that we need to have the market very nearby so that within 24 hours we can able to provide the service, because these are perishable items. We cannot go for storing for weeks. So services are promptly required very often. A shelf life of the product is low. Where the shelf life of the product is low, if the market is nearby, then that is the good for the plant. Plant location evaluation methods. Actually, when we go for evaluating a location of the plant, different methods we normally go for analyzing. So these methods actually are like your cost volume analysis, factor rating method, center of gravity method, transportation model. Cost volume analysis, also known as break-even analysis. Then factor rating method, we go for analyzing different factors. Cost volume analysis is we are going on discussing the volume of production with respect and what is the cost associated with it. Then factor, we go for analyzing different factors. Center of gravity method is also one type of method for analyzing plant location. And transportation model, we have different transportation models. We have already these things discussed in transportation problem, that is linear programming. So we'll discuss one by one. First one is our cost volume analysis. In cost volume analysis, we go for analysis. This is also called a quantitative analysis, because we go for analyzing in a quantitative terms. Means how much quantity we are going to produce, what is the volume of production, and what is the cost associated with it. So this is also called a break-even analysis. So determining a fixed and variable cost, we have to go for analyzing the fixed cost and also the variable cost, so that we can go for finding the total cost. Then plot total cost. This is the method of cost volume analysis. Then determine the lowest total cost. We have to find the fixed cost and variable cost. Then we go for finding the total cost by adding fixed cost and variable cost. Then what is the lowest total cost in the different locations? If 3-4 locations are there, what is the lowest cost? We have to go for choosing that location. Where the total cost is lowest or lower among the different locations, we have to go for finding that location. What are the assumptions for this type of analysis? Fixed costs are constant. Variable costs are linear. Output can be closely estimated. Only one product is involved. Here we are not considering multiple products. We are only considering a single product. Here fixed costs are constant. It's not varying. Variable costs are linear, and output can be closely estimated, and only one product we are considering here, not multiple products. The cost volume analysis is also an economic comparison of location alternatives. These things we have already discussed. Let's discuss the cost volume analysis. Here if you see, one question is given, that is the locational cost volume analysis example. 3 locations are given. Here the expected volume that we are going to produce is 2000 units. The expected volume is 2000 units. 3 locations are provided here. One is Athens, one is Brussels, one is Lisbon. What is fixed cost? Fixed cost for Athens is 30,000, for Brussels is 60,000, for Lisbon is 110,000. Okay. And what is the variable cost? Variable cost for Athens is 75, for Brussels is 45, for Lisbon is 25. So this, up to this, it will be provided in the question. We need to calculate the total cost. See, what is the expected volume of production? Production is 2000 units. If the expected volume is 2000 units, means we are going to produce 2000 units. Our expected volume is 2000 units. So we need to calculate the total cost. This part will not given in the question. Only the locations will be provided, the fixed cost will be given, and the variable cost will be given in the question. We need to calculate the total cost. So what is the method of calculating total cost? Total cost equal to fixed cost plus variable cost into the volume of production. Variable cost means 75. Fixed cost for Athens. Suppose for Athens, fixed cost is 30,000. 30,000 plus variable cost is for one product. For one unit of production, the variable cost is 75. So 75 into 2000 we are producing. So 75 into 2000 we need to calculate. Then we need to go for finding the total cost. See, here we need to calculate the total cost by, suppose fixed cost is 30,000, then we need to plus 75 into 2000. So in total, if you see, it will be 180,000, or you can say 1,80,000. Now we need to do one thing. We need to plot a graph. How we are going to do? First, we need to calculate the total cost for each location. For each location, we need to find the total cost. Because we know our expected volume, production is 2000, and for each location, first for Athens it is 75. We need to calculate, it is 180 total. Like Brussels, 60,000 plus variable cost is 45 into volume is 2000. Like that we need to calculate for each location what is the total cost. Then what we need to do? We need to go for plot the graph. If we see, the highest total cost for the location is 1,80,000. What is our volume of production? Our volume of production is 2000. But when we plot the graph, we always plot the volume versus our total cost. This is our total cost. This is our volume of production. If you see, we are producing 2000 units. In our question, it is given that 2000 units. But it is always good to go for little more units. Like this, when we go for plot the graph, we have to take up to, suppose 2000 units we are producing, but up to 3000 we need to take, so that we can go for having this clear graph, and we can have the break-even points. So here if you see 2000, after 2000 units, because this is our level of production 2000, but 2500 we are having one break-even, and up to 3000. So better when in question it is given the volume of production, always take the volume or the units little more the upper side one, like up to 3000 here. So we can have a good graph, and we can go for analyzing the graph also. मीन्स अगर 2000 तक दिया है हमारा वॉल्यूम ऑफ प्रोडक्शन, अगर हम लोग 3000 तक लेंगे तो एक अच्छा सा प्लॉट हम लोग ड्रॉ कर सकते हैं, ग्राफ ड्रॉ कर सकते हैं, उससे हम लोग अच्छे से एनालिसिस कर सकते हैं. सो इट्स बेटर टू टेक more than 2000 units. If you are producing 2000, better to take 3000 units, तो अच्छा होगा. So we know what is the maximum total cost here. If you see, we have calculated here the maximum total cost is 1,80,000. So it's better to take up to 1,80,000 or up to 2 lakh, because we have to go up to 1,80,000 only. But for volume, we need to take some more units, like 3 up to 3,000. If it is giving 2,000, take it 3,000. If it is giving 3,000, take it 4,000. Up to 4,000 you plot, so that the graph will look good and will also have our break-even points for analysis. So see how we are going to plot the graph. First is our Athens. What is our fixed cost for Athens? Fixed cost for Athens is 30,000. Yes, the fixed cost for Athens is 30,000. We are having a point here in the fixed cost is 30,000. So 1 point we get in 30,000. What is our total cost? Total cost for Athens is 1,80,000. So if you see, we'll get 1 point in 30,000 and another 1 point we'll get when we plot in 2000, because our volume of production is 2000. So here only you will get 1 point, that is 1,80,000. If you see 1,80,000 here, we'll get 1 point here. 1 point in 30,000, 1 point in 1,80,000 on 2000. If you plot one graph here, if you draw here 2000, see this is 2000. Here 2000 volume if we are producing, then our total cost is 1,80,000. So we are getting 1 point here. So 1 point here 30,000, 1 point in 1,80,000 on 2000. So we'll give one, we can draw one line here. Yes, one is 30, one is 1,80,000 on 2000. Like that, for Brussels, our fixed cost is 60,000. Fixed cost is 60,000. So 1 point we will get here. Another, if you see, the total cost is 1,50,000. 1,50,000 means this is 60,000, this is 1,50,000. So 1,50,000, 2,000 if you see, okay, this is 2,000. 2,000, you will see 1,50,000 here. 1,50,000 here. Okay, this is 1,50,000. One is 1,50,000 and 60. So we can go for draw one line here with the help of Brussels. Another one is Lisbon. If you see Lisbon, the total cost is the fixed cost is 1,10,000 and the total cost is 1,60,000. So total, if you see the Lisbon 1,10,000 is here. Okay, this is 1,10,000. Another one is 1,60,000, just upper to 150. 150 if you get here, this is 150. So 160 will get here. This is 160. So one line will get for Lisbon, one line for Brussels, one line for Athens. If you see here, we have two break-evens here. We are not going to consider this one because we are producing 2,000. We are producing 2,000 here. So one we are getting in 2,500, one we are getting in 1,000. Right? We are producing more than 1,000 and less than 2,500. So we are not going to discuss about this break-even. We are only discussing this and this, because we are producing more than 1,000 and less than 2,500. So first see what happens here. So one we are getting in 1,000. One break-even we are getting in 1,000 and the other break-even we are getting in 2,500. So if you see here, this one, If we are producing 1000 units, up to 1000, Athens is good because Athens is low cost. If you see the cost here, this is for Athens. As this is our cost graph, y-axis representing the total cost. If you see, we are going producing 1000, our cost is this one. This is cost curve. Athens is good. Okay. If we are producing below 1000 or up to 1000, Athens is good, we can say, because this is our cost curve. These two are higher side. Yes. If you are producing between 1000 and 2500, 1000 and 2500, what is the question given? Question is given 2000. So it is between 1000 and 2500. So which city is good or which location is good? If you see, this is for Brussels. This is for Brussels. If you are producing more than 1000 and less than 2500, we can see this is our cost because these two are in higher side. After 1000 of production, you see Athens cost is increasing. Athens cost is goes on increasing, but Brussels cost is lower. So Brussels is good. After 2500, that's why I said you have to take the volume more, the units more. If it is given 2000 units, then take it up to 3000 so that we can go for analyzing. So 2500, if you see, another one break even we are getting. Right? After 2500, you see the cost of Brussels is increasing, but Lisbon cost is lower. So हम अगर 2500 के बाद हम लोग प्रोड्यूस मोर देन 2500 we are producing more than 2500, then we can say Lisbon is good. But till 2500, Brussels is good. So this is all about our plant cost volume analysis. That's why it is called a quantitative analysis, as we are taking or considering quantity versus our cost, or the volume of production versus our cost. So these are the ways to analyze. Okay. So we can go for having the break-even. We can analyze the break-even points here and we can see the graph. And after analyzing the graph, we can go for choosing the location according to our volume of production. If we are producing 2500, then up to see up to 1000, Athens is good. But after 1000, we can say Brussels is good. Brussels is good till 2500. So according to our question, if we are producing 2000 units, so we can go for choosing the Brussels location. But if we are producing more than 2500, Lisbon is good. So these are the ways we have to analyze the cost. And we go for analyzing the total cost, then which location will be good for us. That we can go for in cost volume analysis. Okay, I hope you understood the video. If you like the video, do subscribe the channel and share with your friends. Thank you so much.